I am Dr. Subbalakshmi, having 30 years of experience in teaching chemistry to college students, both in undergraduate and postgraduate levels. In this video, we are going to focus on Avogadro's number and mole concept. In the previous video, we have discussed that atoms have negligible size and mass. Therefore, IUPAC, the International Union of Pure and Applied Chemistry, has fixed C12 as the standard and introduced the term unified atomic mass, which is also known as AMU or represented by the symbol U. Based on what we have discussed, the following questions can be answered. First question: what is the mass of 1/12 of one atom of C12 isotope? Answer: it is known as unified atomic mass or 1 AMU, which is also represented by the symbol U. Question number 2: what is the value of 1 AMU in kilograms and also in grams? Answer: it is 1.6605 into 10 raised to the power of minus 27 kilograms, and to express it in grams we have to multiply it by 1000, that is 1.6605 into 10 raised to the power of minus 27 kilograms into 1000. The answer is 1.6605 into 10 raised to the power of minus 24 grams. Question number 3: what is the mass of one atom of C12 isotope in grams? Answer: it is equal to 1.6605 into 10 raised to the power of minus 24 grams into 12, which gives the answer 19.926 into 10 raised to the power of minus 24 grams, which can also be written as 1.9926 into 10 raised to the power of minus 23 grams. Question number 4: how many atoms are present in a sample of 12 grams of C12 isotope? To get the answer, the mass of the sample, that is 12 grams, is to be divided by the mass of one atom of C12, also expressed in grams. That is equal to 12 grams divided by 1.9926 into 10 raised to the power of minus 23 grams, which gives the answer 6.022 into 10 raised to the power of 23. This is known as Avogadro's number. This is a mere number and has no unit. The sample of 12 grams of C12 isotope is termed as 1 mole of C12 isotope. What is 1 mole? It is the quantity of any substance which contains 1 Avogadro's number of entities as found in 1 mole of C12 isotope. Just now we have seen that 12 grams of C12 isotope makes 1 mole of that. The entities can be either atoms or molecules or ions or electrons. Now answer this question: what is the value of Avogadro's number? The answer is the value of Avogadro's number is 6.022 into 10 raised to the power of 23. Have you got the correct answer? In other words, we can say that Avogadro's number is the number of entities present in 1 mole of any substance. Carbon, sodium, copper and calcium, all these are monatomic. Their atomic masses are 12.01 U, 22.99 U, 63.54 U and 40.08 U respectively. So 12.01 grams of carbon, 22.99 grams of sodium, 63.54 grams of copper and 40.08 grams of calcium each makes 1 mole of it. Hydrogen is having an atomic mass of 1.008 U and is diatomic. Therefore, 2.016 grams of hydrogen makes 1 mole. The molecular mass of carbon dioxide is 44.01 U. 1 mole of carbon dioxide is 44.01 grams of it. 18.02 grams of water makes 1 mole of it, since its molecular mass is 18.02 U. 1 mole of potassium permanganate is 158.04 grams. Since the molecular mass of potassium permanganate is 158.04 U. To understand molar mass, answer this question. What's the atomic mass of carbon? It is 12.01 U. Since carbon is monatomic, 12.01 grams of carbon makes 1 mole of it, or 1 gram mole of carbon is 12.01 grams. The molar mass of carbon is 12.01 grams per mole. You would have noted the unit in which molar mass is expressed. It is in grams per mole. Copper is of atomic mass 63.54 U and is monatomic similar to carbon. 1 gram mole of copper is 63.54 grams and its molar mass is 63.54 grams per mole. Since carbon and copper are monatomic, the term gram atom can be used instead of gram moles for them. Hydrogen is diatomic, is of molecular mass 2.016 U. 1 gram mole of hydrogen is 2.016 grams. The molar mass of hydrogen is 2.016 grams per mole. The molecular mass of water is 18.02 U when rounded off to second decimal. 1 gram mole of water is 18.02 grams. The molar mass is 18.002 grams per mole for water. So, molar mass and molecular mass are having the same numerical values, but their units are different. Molecular mass is expressed in U, whereas molar mass is expressed in grams per mole. Let us do some exercises. Question number 1. Calculate the molar masses of the following: A. Urea, B. Acetone, and C. Sulfuric acid. The first step in the calculation is to find out the constituent elements in the molecule and also the number of atoms of each element. Then the atomic mass of each element is to be multiplied by its number of atoms. The sum expressed in grams per mole gives the answer. Taking urea, the constituents are 1 carbon atom, 1 oxygen atom, 2 nitrogen atoms, and 4 hydrogen atoms per molecule. Their atomic masses are 12.01 U, 15.99 U, 14.01 U, and 1.01 U respectively. When we substitute, it is 12.01 for 1 carbon, 15.99 for 1 oxygen, 2 into 14.01 for 2 nitrogens, and 4 into 1.01 for 4 hydrogens. The molar mass of urea is 60.06 grams per mole. B. Acetone. It's of molecular formula C3H6O. The constituents of one molecule of acetone are 3 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. Following the same procedure, 58.08 grams per mole is the molar mass of acetone. C. Sulfuric acid. The atomic mass of sulfur is 32.07 U. Following the same procedure, we get the answer that the molar mass of sulfuric acid is 98.05 grams per mole. Question number 2. Calculate the number of moles in the given sample of 45 grams of glucose. In this problem, the name of the substance is mentioned, that is glucose. The mass of the sample is given, which is equal to 45 grams. The number of moles is to be calculated. The first step is to calculate the molar mass of glucose, and it comes to 180 grams per mole. Then substituting in the formula that the number of moles is equal to mass divided by molar mass, that is, mass given in the problem is 45 grams divided by the molar mass of glucose, that is 180 grams per mole. We get the answer 0.25 Therefore, the number of moles in the given sample of glucose is 0.25. Question number 3. Calculate the mass of 2.5 moles of carbon dioxide. In the previous problem, the molar mass and the mass of the sample were known and n the number of moles was to be calculated. Whereas here, the molar mass and the number of moles are known and the mass of the given sample is to be calculated. The same formula is to be used. That is, n, the number of moles, is equal to mass divided by molar mass. The number of moles mentioned in the problem is 2.5. 2.5 moles is equal to mass which is unknown divided by 44, the molar mass of carbon dioxide, which gives the answer 110 grams. Question number 4. Calculate the number of molecules in 0.18 grams of water. The first step is the calculation of n as explained in the previous problem. Applying the concept of mole, n, the number of moles is equal to mass divided by molar mass. It is 0.18 grams divided by 18 grams per mole. Next, substituting in the formula that the number of molecules is equal to n into Avogadro number, we get 0.18 grams divided by 18 grams per mole into Avogadro's number 6.022 into 10 to the power of 23, we get the answer 0.06022 into 10 raised to the power of 23, which can also be written as 6.022 into 10 to the power of 21. Therefore, the number of molecules is 6.22 into 10 raised to the power of 21. To summarize, in this video we have discussed the following points. The first point is mole. Mole is the quantity of any substance which contains 6.022 into 10 raised to the power of 23 number of entities. The entities can be either atoms, molecules, electrons, or ions. The factor 6.022 into 10 raised to the power of 23 is known as Avogadro's number. The second point is molar mass. Molar mass is calculated in the same way as molecular mass. Both are numerically equal, but the units are different. Molecular mass is expressed in AMU, otherwise known as U, whereas molar mass is expressed in grams per mole. The simple sums worked out would be useful to understand the concepts better. Let us meet in the next video to look at some more basic concepts of chemistry. I hope that these videos will be helpful. Thank you.